Okay, today we're talking about all these different ways you can go from one form to another form, and we've already learned all these. The easiest kind is if you ever want general form, that's both this one. Okay, why is that not working? Hold on. No, now it trickled it twice. Nice. Or that one. Those forms, you just multiply it out. And this form, all you got to do is factor it. Okay, so to get from one form to the other, that's pretty easy. Today, you're going to learn to go from general form to vertex form. What does that mean? That means I'm going to show you how to do this. X squared plus 6x plus 1, that's in general form, right? And I can't see the vertex easily, can I? Let me show you how easy it is to do this. I'm going to jump right to the good stuff. Here's an example of one. X squared plus 6x plus 9 plus 1. What just happened there? I just chose this number to be right there because now this thing is going to factor nicely. But if I had that 9 added, do you agree that I also have to subtract 9 to cancel it off? Yeah. It's kind of weird, but if I added 9 to this side, I'd have to add 9 to that side. But if I wanted to, I could subtract 9 here and also add 9 here. That'll also cancel it out. All right, so that's what I do. I added 9 because I knew it would work nice. Why? Because this part here now becomes perfect. It becomes x plus 3 quantity squared. And then negative 9 plus 1 makes negative 8. That's vertex form. The vertex is at negative 3 comma negative 8. That's what you're going to learn to do today. All right, I'm not saying you know it yet, but that's generally going from general form to vertex form. And I'll show you how to do that. All right, so a little bit of review first. What can you find using this? In other words, I already can see something. What can I see from this? The zeros, and they are? Negative 5 and 3. Good. All right, moving on. How about that guy? Well, it's the same basic form. And I can see that 3 and some fraction, I think it would be positive 3/2, yep, would be my two answers. But what did you do to put it into general form? What do you do to get this in general form again? Yeah, you just have to multiply it out. So it'll be 2x squared, that's the first outside, inside, makes negative 6 and negative 3 makes negative 9x, and the last make positive 9. All right, that's general form. So just multiply it out to get general form. All right, I'd like you to take this one and factor this puppy. We're trying to factor it. To factor it, do you get that I should look and see if there's anything in all of them? It's called the 3 letters. What? GCF. The GCF. Look for a GCF. Is there anything in common? Well, you can't use 2 because 15 wouldn't work with that. 3. How about 3? Factor out the 3. See what you have left. 5x minus 6x. Wait a minute. That was weird. X squared. There we go. 5x squared minus 6x. And then what's the next one? Minus 8. Good. Would you assume you could factor that again? I assume you probably could. I wouldn't know for sure until I tried. But to be totally honest, I would probably guess and check it. Unless that was too difficult. 5x and x. And then how do I make an 8? Probably a 4 and a 2. Could be a 8 and a 1. Let me think. Is it a 2 and a 4? Did you figure it out? What is it? Plus 4 and minus 2. All right, and then this outside's negative 10, this inside's positive 4. That makes a total of negative 6. It worked. Cool. All right. Now what can I do now that it's factored? Now I can get the roots, and I can say they're 2 and negative 4/5. All right. This is the general form to vertex form, the completing the square thing. These kind underneath the purple box, these kind are special because they are perfect squares. The way you can tell a perfect square is that if you factor it, it will come out to two of the exact same thing, x plus 6 and x plus 6, for example. Or on this one, I could factor it down to what? X minus 7 and x minus 7. They'll be always identical like that. Why do I want that kind? Because that kind can combine together like this and make up, you know, when you want vertex form, you want something like that, right? That's why we want those perfect squares. So how do you get them to be perfect squares? Well, if you want to get them to be perfect squares, you have to figure out what number at the end would make it work nicely. And there's a little German boy that's going to help us to do this. And you can call upon little Hoffensquare anytime you want to, and he'll come and help you. Little Hoffensquare. You have any clue what I am talking about? Oh, some of you do. Half and then square it. Okay, so what's half of 10? 5 and then 25. There we go, 25. Take half of it, 5. Square it, 25. All right, take half of negative 6. What's that? Negative 3. Square it, 9. Keep going, and you're going to hit one that's going to confuse you in a moment, and I'll see if you can handle it. Give it a shot. I'm going to pause for a second. This one's going to need to be done algebraically. See if you know what to do. Your answer will have a B in it, I'll tell you that. All right, here's what you should have thought. Okay, half of 4 is 2. 2 squared is 4. That one's 4. And this one, half of B, I'd call that B over 2. Another option is 1/2 B. Either one of those ways works. But then we'll have to square it, right? So I just go like this and say square it. Now, could you say B squared over 4? Yeah, that'd be a great answer too. Another option, 1/4 B squared. That's another option. All right, moving on to E as an elephant. Half of 7 is just not very nice because it's a decimal. It's 3.5. You can say 3.5 squared. That's okay. Totally okay. But there's another way. If I want to do it with the fraction thing, which, believe it or not, is actually easier on this kind of a problem, you say 7/2 squared. Then I can do that in my head. 3.5 times 3.5 is really hard, but 7 over 2 squared is easy. What is it? 49 over 4. And you can leave it like that. Remember how we like not irrationals, but impropers. It's okay to have like a bigger number on top. So 49/4. All right, moving on. Don't forget to ask the German boy for help. This one. Is that set up perfectly to be a perfect square? No, because half of 8 is 4, and 4 squared is 16. So it's not set up perfectly. So here's how you do it when it's not set up perfectly. That's kind of the point. If it is set up perfect, then you didn't really need this. All right, so what do? My first piece of advice is you take the 20. You don't have to do this one. You can just watch me for a second. And I'm going to move the 20 over there because I need some room. Then, half and square, half of 8, 4, 4 squared, 16. If I put a plus 16 here, I would have totally changed my equation, and that's not okay. So I have to balance that out with minus 16. You just do them one right after the other. See how easy that is? Plus 16 and a minus 16. Because then it's like I never did anything. If you actually add the 16 and the minus 16. Now, why did I do it, though? Because this part right here is perfect. And it actually comes out to x plus 4 and x plus 4. But you can skip that, really, because I'd really rather have you write it a different way. How would you think I would want you to write that? X plus 4 squared. Because we're trying to get vertex form, and they always look like this. And I'm almost done. How do I get the last number? Negative 16 plus 20, which makes plus 4. Look at that. I got vertex form. Is your iPad talking to you? All right. All right. Try this one. Now, some of you are ready for this and can just do this. Go for it. But if you're not quite ready, all I'd ask you to do is write it down, except move the 50 way to the right to give yourself room to work. And the rest of you that know how to do it, go for it. You can do this. You already know enough. Write it in vertex form when you're all done. I can tell there's a few people that are just watching because they're not sure what to do. But there's a lot of you that are cranking it out, and that's awesome. I'll show you in a moment what you should be doing. Okay, ask the German boy. What's half of 14? 7 squared. Half and square, 49. If I use plus 49, I have to use a minus 49. And then this part right here is perfect. And that means that it's y equals x. And be careful here, minus 7 squared. If I'd used the plus to get, I would have never had a negative 14. And then the last part is those go together and I get plus 1. Raise your hand if you had that one right. Holy cow, in one example, you got it. So that's impressive. Let's try one more just to make sure it's set. Make sure you really get it. I wonder if in Germany right now there's a little boy running around named Hoffensquare. Something close to that at least. Hoffensquare, come get your pudding. And I'm moving the plus 94 way over there. And then I'm going to say, I don't want 94. I wanted what? 100, because that's half of 20 is 10. 10 squared is 100 minus 100. This part's perfect. Y equals parentheses x minus 10 squared. That goes together, makes negative 6. Raise your hand if you had that one right. Awesome. Okay. You know how to get to vertex form from general. That's called completing the square. Because this is a perfect square, and that's why it's called completing the square. I know nothing about this actually is square-shaped, but that's what I should officially call it, complete the square. All right, and your homework looks like that, 7.3 worksheet A. I'm going to make your life just a little bit better because on 7.3 worksheet A, there is a section at the beginning on factoring. My classes, you guys are so good at factoring by now, there's no need for those. You may skip the first 4 problems on the worksheet. And from there, yep. Then the next part is what value is needed to complete the square. Those should be easy for you, but since it is new, I'd like you to do those. So use half and square to get number 2 done. That'll be easy. Now let's move on to number 3. Complete the square. All right, so this is like those problems we just did a second ago. And I can't scroll down unless I move this to the right. So, yeah, you use half and square again. Y equals x squared minus 6x, and then half of 6 is 3, and 3 squared is 9. And if I put a plus 9, I also have to put a minus 9, and then I also have the plus 5 still at the end. I got moved way over. This guy gets bumped to the end. Now, this part's perfect. Y equals what? Minus 3 squared. Good. And then the last part? Minus 4. And then if you go to that spot, 3 comma negative 4. Don't make the mistake a lot of people do, which is to go to negative 3 comma negative 4. You got to change that middle one to positive 3 comma negative 4. So then your graph looks like positive 3, negative 4. That's down here. It's so easy to graph once you have it in vertex form. You know what the vertex is. Now you can just go over 1, up 1, over 2, up 4, over 1, up 1 this way, over 2, up 4 that way. And remember, I don't require you to connect those dots with a line because it just makes it messy and hard to see your dots. And there we go. That's all there is to it. So today was a fairly easy one. Tomorrow we're going to get into kind where they're tougher, where the lead coefficient is not 1. Sorry, not tomorrow. Let me show you what I mean. And maybe some of you guys could already handle this, but 3x squared plus 2x plus 7. If I had to do this with complete the square, the tricky part is there's a number up in the front. That makes it significantly harder. Okay, I'll show you how to do that on Monday. Okay, that's all I got for you for today.